Hi guys, welcome back. Domain-3 Architecture and Design, Chapter 3.6, Summarize Secure Applications Development and Deployment Concept. So, secure software starts with the secure development and deployment system. Only if your software product was designed, crafted, and distributed in a secure fashion is it possible for the final production to provide reliable and trustable security. So in this video, we are going to discuss several aspects of secure software deployment and development. So let's go for the topic. So application security. So this is a list we are going to see: development lifecycle models, secure DevOps, compiled and versus runtime code, version control and change management, provisioning and deprovisioning, secure coding techniques, code quality and testings. Software development lifecycle models. There's two topics here. So Waterfall versus Agile. So Waterfall is systems requirement gathering steps. What we perform here is mainly requirements gathering, design, implementation, coding, testing, verification, deployment, and maintenance. Each stage is completed self-contained and completed in order. So a development lifecycle model is methodical ordering of a task of creating a new product or revising an existing one. A formal software development lifecycle SDLS model helps to ensure a more reliable and stable product by establishing a standardized process by which new idea become actual software. Software development has only existed as long as computers, less than 100 years. Modern software is only 30 or 40 years old. The earliest forms of software development management were forged in 1970s and 1980s, but it wasn't until 1991 when the Software Engineer Institute established the Capability Maturity Model (CMM). The software management concepts were formally established and widely adopted. Waterfall versus Agile. There is perhaps the oldest and most structured SDLC model is Waterfalls. The Waterfall method is also referred to as linear sequential lifecycle model. It is simple to understand and use, but is slower and more rigid than some other models. Each individual phase is completed before the next phase starts because the outcome of each phase acts as an input for the next phase. If the first phase gets behind schedule, the entire project ends up behind. Additionally, when a phase is completed, there is no going back to make adjustment. Changes cannot be made until the software is in the maintenance phase. This model should not be chosen for a long, ongoing project or when flexibility is primarily requirement. Agile SDLC model breaks the development into cycle. Agile combines iterative and incremental process models to achieve rapid delivery of a working product. This tends to be more realistic development approach. The Agile method is well suited for applications that are updated frequently, such as with the PayPal and Google apps. The Agile method provides ongoing release, and each release contains incremental changes. Testing is conducted with each new release or iteration. Iterations generally last 1 to 3 weeks. The Agile model relies heavily on customer interactions and can easily be derailed if customer directions is not clear. The model is not suitable for products that require complex dependency. So I give you the small exam tips. So it will be very useful for when you guys when you guys go for exam. So the main difference between Waterfalls and Agile have to do with the planning and adjustment. The Waterfalls SDLC model is traditional. It starts with a defined set of requirements and well-development plan, and it confines adjustment to the current development stage. The Agile SDLC model starts with less rigorous guidelines and allow for adjustment during the entire process. Move on, next slide. Secure DevOps. So secure DevOps is development and operations originated from recognitions that organizational infrastructure should support development of the SDLC along with the product capacity. Secure DevOps includes security in the SDLC, which was not always major concern in developing software applications. When this topic was initially introduced, software developers had a negative reaction because it meant great programming effort and delays in software and release cycle. The evolvement of secure DevOps has produced some best practice for increased security of development applications that include few of these. Address security concern. You can see the address security concern at beginning of the project. Add automated security testing technique. The other one is having security practice integrated into entire software delivery cycle. Security integrated into all of your development operations, which includes database designs, programming, and infrastructure. So from your secure DevOps perspective, software should be secure and resilient. Developers should be proficient with the tool and thought processes to develop software that can be withstand attacks and continue to function instead of one that only seek to prevent attacks. So these offer more flexibility in mitigate attack risk. A secure SDLC requires the organizations to focus on practice such as security automations, continuous integrations, and infrastructures as code. You can see on the picture planning in the development side. So planning, create, verify, pre-production, release, configurations, and on the operation side, configuration, release configurations, develop, detect, and response, predict, and then adapters. So this is a monitoring analytics for both sides, the development side and IT operation side. So let's move on. The other sectors. Yeah, you can. These are continuations here. So as I said here, the continue integration, secure in every steps with updates from a centralized and controlled repository. And the secure automation is a repeatable scripted task. Baseline is a reference points that requires compliance and approval for approval of a set of predefined project requirements to prevent uncontrolled and change and lessen vulnerabilities. Immutable systems and no change to systems in place. They maintain and non-documented and reputable configurations. Infrastructure as code. Programmable infrastructure configuration is included with application code. Let's go for that one by one. First, the continuous integrations and security automations. First, we can see the first two. The main DevOps concept is continuous integration, CI, a process in which the source code update from all developers working on the same project are continuously monitored and merged from a central repository. The repository is updated when a new commit or permanent change is detected. Software builds are triggered by every commit to repository. CI continuous integrations helps avoid code merging conflicting that can arise when developers keep a working local copy of software project for a long period of time. The continuous integration process is automated. A centralized server continuously pulls in new source code changes as they are committed by a developer. It then builds the software applications and run unit test suites for the project. When a process fails, the CI server fails the build and immediately notify the project team of the failure. So I give you the examples for this. Continuous integration server are also called build server because of their main functions. A CI server compiles, builds, and tests each new version of code committed to the central repository without user interactions. Okay, so all members of the team are notified when code is the repository fails. This prevent a loss in team productivity by limiting the chance for merging issues and network due to the broken code bases. The CA process is based on the automated configuration and deployment scripts. The automated processes are critical to ensure the software operates as intended. So the second is a baseline. Baseline is an SDLC baseline is a reference point in the process that is noted by the completions and subsequent approval of a set of predefined project requirements. The primary goal of a baseline is to prevent uncontrolled change and lessen project vulnerabilities. So this is accomplished by implementing formal change control process for a key deliverable at critical points in the SDLC. Baselines provide the following. One is a measurable progress points. Second is a foundation for change control in phase that follow. Third is a sound reference points for future project, including intermediate as well as the final points. A typical project contains baselines such as functional, allocated, design, several testing point, and product and operational. So they can also be used to establish the required software and hardware components necessary for a specific release. In DevOps, baseline and metric are typically used to record and track progress. So another one is immutable system. So immutable system is mutable means that after something has been created, if changes are needed, you modify the one you already put in place. This is done primarily to avoid the cost associated with this creating new one. Traditional software programs and servers functions in this way. So mutability is leading causes of software bugs and configuration error. Immutability means it means that a value program configurations or a server is never modified in a place. If changes are needed, a new one is built or configured and the old one is removed. I give you the exam tips for this. Immutable increase the reliability of system and software behavior while reducing software development and deployment time. This is a very useful piece of information. So the concept of immutability has grown with the DevOps because the replacement and deployment costs have become very inexpensive. This produces more frequent repeatable updates and more reliable service with less downtime. An immutable server has known, documented, repeatable configuration that is source control. A new development server is exactly the same as a new production server because both were created using the same deployment files. This process also makes adding servers easiest when the workload increases and supports a faster recovery from disasters because the same deployment files are used in the new deployment. Other one, infrastructure as code, IAC. So infrastructure as a code is also known as programmable infrastructure. This means the infrastructure configuration can be incorporated into application code. IAC enables the DevOps teams to test applications in production-like environment. From the beginning of the development cycle, validations and testing can then prevent common deployment issues. The previously mentioned automations framework, Chef and Puppet, provide the capability to automatically configure the infrastructure layers and operating system layers through the script or code. So developer write the infrastructure that the application code runs on into the program. So basically all configurations are written into the script or code, eliminating the need for the full environment. ISC provide the following benefits. One is act as a documentation reference point for the application infrastructure. Second is provides a consistent starting point for deployment. Third is support infrastructure independence. The other one is the last one is avoid infrastructure inconsistencies. So IAC is based on using proven coding technique and campus infrastructure. So let's move on the next topic. Next slide. Compile versus runtime. So the quality assurance and testing process directly affect code quality. The earlier defects in software are found, the easier and cheaper they are to fix. The benefit implementing a sound QA and testing process for outweighing the associate cost. The SDLC must include quality code and testing. Report of website vulnerabilities and data breach are reported in the news almost daily. Providing quality software also builds a positive reputation for the organization and provide customer confidence in the product they are purchasing. So there is a static and dynamic analysis are there. So static analysis is performed in your non-runtime environment. Typically, a static analysis tools inspect the code for all possible runtime behavior and looks for probability code such as backdoor or malicious code. The same kind of compiler is used in static code analysis that is used to compile code. Integrating a source code analysis into a compiler makes the best use of the compiler and reduce complexity. The code analyzer can use pre-existing compiler data flow algorithm to perform analysis. The analysis is a complete program analysis that checks complex code interaction. Static code analysis can detect a wide array of vulnerabilities and including memory leaks. So dynamic analysis, as noted in the previous sections, static code analysis is performed without executing any code, but dynamic code analysis is based on observing how the code behaves during execution. Dynamic analysis is done while the program is in operation and monitoring functional behavior and overall performance. Dynamic analysis uses a technique called fuzzing, which enable an attacker to inject random looking data into a program to see if it can causes the program to crash. So I give you the exam tips. Fuzzing is a black box software testing process in which semi-random data is injected into program or protocol stack to detect bugs. Fuzzing is based on the assumptions that every program has bugs. Several types of fuzzing exist. One is application fuzzing, protocol fuzzing, and file format fuzzing. So application fuzzing is the attack vectors are within its IO. For example, the user interface, the command line options, URLs of forms, a user generated content, and RPC request. Protocol fuzzing, forged packet are sent to test application, which can act as a proxy and modifying requests on fly and then reply them. File format fuzzing, multiple malformed samples are generated and then opened sequentially. When the program crash, debug information is kept for further investigations. So an advantage of a fuzzing is the test design is generally very simple without any presumptions about system behavior. This approach make it possible to find bugs that human test fine test would have missed. In some closed application instance, fuzzing might be only means of reviewing the security quality of the program. The simplicity can be disadvantaged because more advanced bugs will not be found. Additionally, if your fuzzer is a very protocol aware, it will tend to miss odds errors. A random approach is still a good idea for best result. Fuzzing can add another dimensions to normal software testing technique. So you can see the method of creating the list there. Method for create executable code, compile code, use a compiler program such as C or C++, runtime uses interpreter such as Java or .NET. there is a generally faster but less secure. So this is a bullet point. So you can also try that. You can also find more information about that compiled versus runtime code to get more information. So let's move on the next slide. Change management, versions control. So you can see the go hand in hand. Control and manage software changes, a need for quality, security, and the version control, as known as the source control, so prevent tampering or changing the source code or executable, tracking software file change or application code changes, use distributed storage for code, so Git or GitHub or subversions. So the software change management process is similar to the IT change management process. Change management process are used to properly control and manage changes to the software. The primary functions of a change management is managing project or product changes so they meet both the defined scope and customers' expectations. The capability to manage changes is necessary component for quality in software product. In an Agile or DevOps environment, change management has a stronger focus on responsiveness to requests for a change and swift implementations of approved change requests. So this is accomplished by using advanced automations and control tools to streamline the change and release management process. So different types of management often are consolidated into one pipeline. Change management goes hand in hand with the version control. So you can see here, the change management tools often are used to handle versions control. So version control or source control is a part of software configurations or change. So it's a change management and manage change to collection of informations. Versions control tracks changes in the source code and providing software integration during a development stages of the SDLC. Strict versions control prevents tampering with the source code or executable. So version control is done through a system, software tools, or applications that track software's files changes and provide a way to manage change to source code over time. So most version control systems use some form of distributed storage. For example, one tool might use one master server, while other tool might use network of distributed server. So version control benefit includes the listed there: historical data on change to file, branching and merging capabilities, traceabilities. So when used in a DevOps environment, version control is generally used as predictor of performance because it can provide metric for process improvement services. So let's move on next topic: provisioning and deprovisioning. So provisioning is a creation of update of a resource. Deprovisioning is the removal of a resource. Provisioning and deprovisioning are part of organizational lifecycle management and can affect any number of assets. Software provisioning and deprovisioning are generally automated process in which software package are made available to computers and used through a self-service protocol. Provisioning can be integrated with the other technology as well. So this is especially true in cloud-based environment. For example, in one particular implementation, VMware used a private cloud based on a software-defined data center architecture to automate the provision process. The result included a reductions in applications environment provisioning time, and increasing in developers productivity, improved capacity, and significant cost saving. So let's move on next topic: secure coding tech. So attacks against software vulnerabilities are become more sophisticated. Many times a vendor misses a vulnerabilities and then when it is discovered doesn't address it for quite some time. The vendor decides how and when to patch the vulnerabilities. As a result, users have become increasingly concerned about the integrity, security, reliability of a commercial software. Software assurance describes vendors' effort to reduce vulnerabilities, improve resistance to attack, and protect the integrity of products. Software assurance is especially important in organizations where users require a high level of confidence that commercial software is secure as possible. Secure software is achieved when it is created using a best practice for secure software development. The security of a software code has come to the forefront in recent years, and coalitions have been formed to improve it. Additionally, the industry offers certifications in the software security. The Software Assurance Forums for Excellence in the Code works to identify and promote best practice for developing and delivering more secure and reliable software, hardware, and services. It was founded by EMC, Juniper, Networks, or Microsoft, SAP, Symantec. So organizations such as ISC, Square, so offer a certifications so specifically geared towards secure code design, such as certificate secure software lifecycle professional. So the various stages of secure software include design, coding, secure code, source code handling, and testing. So security must be implemented from the very beginning. In the early design phase, potential threat to application must be identified and addressed. Organization must take the consideration way to reduce the associated risk. This objective can be accomplished in a variety of ways, such as threat modeling and mitigation planning, including analyze potential vulnerabilities and attacker vectors from the attacker's point of view. So when the design is complete, the secure programming practice must be implemented. Secure coding skills require inspecting the application source code to identify a vulnerability created by the coding error. So you can see the list: the authentication, proper error handling, proper input validations, normalization, stored procedures, code reuse, dead code, use the third-party library and SDKs. So these all are the very common, very important on the secure here on the secure coding techniques. So the proper, you can see the authentication. We start from the authentication. So authentications is hard coding credentials into code, a use of cookies. So these are the very important on this, the authentication. So when we go for the authentications, and the second one is a proper error handling. So when error occurs, the program should fall back to a secure state. So this is generally known as a fail secure design. So however, the programmers must code this into the application in order for a true fail secure response to their take places. This should include error exceptions handling. When a procedure or input results in a causes or an error, the system should revert to a more secure state. So this could include resetting back to the previous state of operations, rebooting back into a secure state, or recycle the connection state to revert the secure communications. So errors should provide minimal information to visitors and users, especially outside external visitors and users. So all detailed error message should be stored in the accesses restricted log files for the program and administrator. So whenever an exception is encountered, it should be rejected and the failed secure response should be triggered. Third is a proper input validation. Scrub and validate input from outside untrusted resource, use of default value and character limitations. Meaning, so input validation is an aspect of defensive programming intent to ward off a wide range of input-focused attacks such as buffer overflow and fuzzing. Input validation check every input received before it's allowed to be processed. So the check could be a length, a character type, a language type, a domain, or even a timing check to prevent unknown, unwanted, or unexpected content from making it to the core program. So normalizations. Normalization is a database programming and management technique used to reduce redundancy. The goal of a normalization is to prevent redundant data, so which is waste of space and can also increase processing load. A normalization database is more efficient and can allow for faster data retrieval operations. Removing duplicate and redundant data ensure that sensitive data will exist in only one table and database rather than it being repeated within many others. So this can reduce the difficulty of security sensitive data by allowing database security manager to implement access control over the original data source instead of having to attempt to lock down every duplicate copy. So the other is stored procedures. A stored procedure is subroutine of a software module that can be called on access by an application interacting with the relation database management system or DBMS. So stored procedure may be used for data validation during input, managing access control, accessing the logic of data, and more. Stored procedures can make some database applications more efficient, consistent, and secure. So then code reuse, a dead code. Code reuse is the inclusion of a pre-existing code in a new program. Code reuse can be a way to quicken the development process by adopting and reusing existing code. However, should be taken not to violate copyright or intellectual property restrictions when reusing code. It is also important to fully understand the reuse code to ensure the backdoor or other exploitation flaws are not introduced to the new product through the recycle code. Dead code is any section of a software that is executed but whose output or result is not used by any other process. Effectively, the execution of dead code is waste of time and resource. Programmers should strive to minimize and eliminate dead code from their products in order to improve efficiency and minimize the potentials for exploitable error or flaws. So dead code is sometimes used as part of obfuscation. So then use of third-party libraries and SDKs. So third-party software library and software development kits are often essential tools for a programmer. Using pre-existing code can allow programmer to focus on the custom code and logic. So software development kits provide guidance on software crafting as well as solutions such as special APIs, subroutines, or stored procedures, which can simplify the creation of software for complex execution environment. However, when you are using third-party software library, the pre-crafted code may include flaws, backdoors, or other exploitable issues that are unknown and yet undiscovered. Attempt to vet any third-party code before relying on it. Similarly, an SDK might not have security and efficiency as top priority, so evaluate the feature and capability provided through the SDK for compliance with your own programming and security standard. Let's move on. So continuation, secure code techniques. So code signing, data exposure, encryptions, obfuscations, memory management, server side versus client side execution and validation. Code signing is signing executable code using a certification-based digital signatures. A proven authority, proves the author's identify and provides code integrity. So the most common example of code signing is drivers. For examples, by default, Microsoft operating systems block the installation of unsigned drivers. Code signing consists of signing executable using a certification-based digital signature. This is done to provide trustworthiness in executable. So code signing proves the author's, as I said before, author's identity and provides reasonable assurance that code has not been tampered with since it was assigned. So the two types of code signing certification or organizational code signing certifications, what are issued to organization, and individual code signing certifications which identify independent developers. The certification is issued by a CA, certification authority, that validate the legitimacy of the issuer. If a nefarious person steals a legitimate certificate, the certificate can be used to sign malware. So this makes the program seems legitimate to unsuspecting users. For the reason, many criminals and many cyber criminals and cyber criminal groups such as Suckfly or steal certification and using them in malicious attack. So data exposure, encryption of sensitive data at all times, meaning, so according to a best practice, sensitive data should be encrypted at all times, including while in transit and rest. So data exposure often occurs in applications because sensitive data such as credit card numbers, personal health information, authentications, credentials are not protected during transits. Other times, sensitive application data is stored unprotected, exposing the data. Mitigations of a data exposure should be addressed using the SDLC framework along with best practice. Addressing a data exposure in both the requirements and design phase permits the organization to take a holistic approach to mitigations. Security best practice dictate the following method be included when building applications. So one is a data validation, second is authentication and authorization, and third is encryption. So encryptions. So what is encryption? Encryption tends to be a catch-all solution. When in doubt, encryptions, obfuscations, and then we will talk about this later. The obfuscations are used software development process to prevent the software from being reversed engineering. So this practice protect the trend secrets and intellectual properties of organizations. Encoding technology have been developed that effectively hide executable program code in plain sight and don't require the code to be decrypted before it's run. So these allow software to run but not to reverse engineer. Like you can say the standard encryption algorithm, hashing and digital signatures or TLS for data and data transits. So there's the best example for this. So obfuscations. So obfuscation has been used for long time in interpreted language. This is often done by shortening functions and variable names and removing white space. So the best way to see the prevalence of the technique is to view the source code of web page such as Google. So when used in malicious manner, obfuscation usually goes one step further by encryption the underlying source codes, which is then decrypted on the fly when the code is run. So the memory management. Memory management optimizes performance by assigning blocks of memory to various processes and programs. It makes sure that sufficient memory is available for any currently running programs or progresses. Memory management is used in all computing functions and plays an integral part in programming applications. Application memory management is based on allocations and recycling. Programs are written to request block of memory, and the allocator is used to assign that block to the program. When the program no longer need to data in the assigned allocator memory blocks, the blocks can be reassigned. So proper memory management is in software development is impressive because many vulnerabilities take advantage of improper memory management technique. For example, buffer overflow vulnerabilities are based on the capabilities to overflow the memory allocated for a variable. So suggestions for the mitigations vulnerabilities such as buffer overflow, including as below. So the following one is a verifying that the buffer is as large as specified. Second is use input and output control for data that is untrusted. Third is properly free allocated memory upon completions of the function. Fourth is don't use known vulnerability functions. So These are the clearing sensitive information stored in a memory to avoid unintentional disclosure should also be included in the memory management practice. The last one is server-side versus client-side executions and validations. Client-side validations occurs when the data entered into a form is validated through a web page script through the user browser before the form is posted back to the originator server. Client-side validation is often used for convenience because it gives immediate feedback to the user. If incorrect data is input, client-side validation is an insecure form of validation in web application because it places trust in the browser. So these form of validations allow the client to execution validations and can be easily bypassed or altered. In addition, it allows the user to view the page code through the built-in browser capabilities. When an application accepts input from the client, the input should be validated on the server for type, length, and range. So server-side validation occurs on the server where the application resides. So server-side validation helps protect against malicious attempts by a user to bypass validations or submit unsafe input informations to the server. Server-side checks are more difficult to bypass and are more secure from of input validations. Several techniques on the server side can improve validation, including identifying the acceptable data input type that is being passed from the client, defining the input format and type, building a validator type for each input type, and situation the validator routines at the trust boundary of the applications. So yeah, your recommended approach is to initially perform client side validations, and then after the input form was posted to the server, perform the validation a second time using a server side validation. So let's move on next slide. Exam preparations. Which of the following would be the most secure way to deploy a legacy application that requires a legacy operating system? Answer: A. Sandboxing. Answer is sandboxing. Second one, John wants to reduce the probability of SQL injection attacks against the company web servers. What secure development measure would work best? Answer: B. Input validations. Answer is input validations. So that's it guys for this video. So please subscribe my channel, press the bell button to get more update. Please share the video if you like. Thank you so much. Have a good day.